Hello, welcome here guys. The video you're about to see is taken from a full course you can find on academy.einco.com. So if you're looking for more context, more lectures, more videos, more explanations, you can find it for sure there. And now you can enjoy the video. In this lecture, I gave you some additional information about the Ethereum blockchain. In this one, I will continue with some practical stuff. So what about to create a smart contract? Okay, let's do it. Let's go to our browsers. And first we'll create a smart contract in Remix IDE. So let's open here a new tab and let's search here for Remix Ethereum. Remix Ethereum. So Remix is IDE, Interactive Development Environment, all right? And we can access it here, remix.ethereum.org. Let's access it. And with the Remix Ethereum, we can do powerful stuff. We can create a smart contracts. We can deploy them also to mainnets, to the test nets, and we can test the smart contracts. And also we can deploy, as I mentioned, we can also create a smart contract and deploy it to the mainnet. But we'll be using it mainly for testing purposes to show you some basic stuff. Okay, so this is Remix IDE. And we'll go, you should have here some folders on the left side. I hope it's visible for you. I can zoom it in, I guess. All right, so on the left-hand side, you have a few folders. What we are interested in is only contracts folder. I'm not going to create any contract. We'll be creating contracts later in our coding editor. And now we can access here some contracts that are already created here for us. In some cases, something has changed and you don't see here these contracts. Don't worry, you don't need to do actually anything here. You don't see these contracts, just watch my screen and see what I will be doing later. I'll be coding the contract in our coding editor. Okay, so this is here a very simple smart contract called storage. Okay, so as maybe some similarity with JavaScript or also other programming languages, we are creating usually classes, right? And in the smart contracts, you are creating contracts. Okay, so in JavaScript, you would see maybe something like this, class storage. Here you see the contract storage. Here you see the structure called int 256. This means unsigned integer 256. So this is the integer of 256 bits length. Okay, that's a number. So we'll be storing some number here. You have here two functions. You don't need to know any details about them. You just need to know that there are functions. One function is to storing the numbers. We are storing the number. We are receiving into the number here on the storage. And one function is used for retrieving this number from here. So very, very, very simple smart contract, just serving us just a simple storage of numbers. It doesn't have any really very practical usage in big scale, but it's very good for a testing and just to show you some basics. All right, so that's our smart contract. But when we want to interact with our smart contract, we need to deploy it to the network. Okay, but how can we do it? Actually, first thing, we need to compile it. We need to compile it as in the bytecode, as I was mentioning. We need to create this byte representation of the smart contract. So to get a smart contract, we need to transform it into bytecode. Also about the bytecode in much details, I'll be talking in another lecture. Okay, so when we want to compile this smart contract, we can compile it here on the left-hand side. And also this, I didn't tell you this here, this pragma Solidity is just specifying a version of the compiler for this Solidity file. Okay, so it has to be larger than 0.70 and smaller than 0.90, the compiler. Okay, so now let's go to the left-hand side here to this Solidity compiler here. We are specifying here a version of the compiler. We have here multiple versions. I will go with the 0.8.4 version. You can also click at the same version. And what we'll do, we'll compile storage.sol. Okay, we don't need to change here anything. Language will stay same. EMV version will stay the same. It's a compiled file. The default also what's EVM. It's very important, but we'll handle it later. I will be talking about the EVM later. Okay, so let's compile this storage.sol into bytecode. As soon as I will click compile storage, actually I got here error. I was expecting to see here a result of this compilation process. Okay, it's not here, but no worries. Our contract should be compiled anyway. You can see here this green check mark. Everything went good, so that's actually all right. Okay, so code was compiled. We can see here compilation details. Just it will not say much to you right now, but I want to show you that when you click compilation details, you can see the bytecode of your code, and here is the code which will be deployed to Ethereum blockchain, basically. Okay, so you can see the sequence of hexadecimal, the hexadecimal characters. Okay, and that's the code you see here, the storage in this high level programming language compiled into this this bottom level, not bottom level, this base level. Okay, so into bytes, into sequence of the bytes, where each bytes, which you can reference as the opcode or operation code, means something else. But about this later, guys, I just want to show you that this code, what you see, is compiled into this opcode, so 60806040, and so on. This will be deployed to Ethereum. Okay, now we want to deploy this smart contract. So when we want to deploy it, we'll go here into this menu here, or deploy and run transactions. As the environment, we will choose here JavaScript virtual machine. So this means this smart contract will be not deployed into to any blockchain, to any network, but it will be run here locally in a JavaScript. So this will be some kind of simulation. We have also accounts created for us. We have a couple of accounts we can use, and each account has 100 Ether. All right, and then we have some gas limit. About gas limits, I will be talking later because that's for a separate lecture. What I can tell you now, gas limit serves as the way to pay for the transactions, because in Ethereum network, you need to pay for the transaction. So when you want to create a transaction or you want to deploy smart contracts, you need to pay for it, and you are using these gas units here for it. But about this, again, I'm saying always later, but yeah, we need to be patient, and we need to get through all of the lectures. Okay, so when we are happy with the settings, which the default settings should be completely fine, we can click here deploy, and this will be deployed to the network. Of course, everything went fine because this is a simulation, but you can see here when you click on the right side that the transaction has been made. Okay, so you can see through transaction, mined, and execution success. Here you have a transaction hash. What does it mean also? Hashes are a very important part of the crypto network, so this will handle in a separate lecture. What's important here is that the transaction was made from this account. You can see it here from, and that's the account here. This is 0x5b3. This is the account the transaction has been made from. And you can see we have paid for a transaction because we don't have any longer 100 Ether, but we have 99.9999, okay? And there is also gas we have to pay for, and execution costs. That's not really important, but what's important here is the from and the to. And the to here, you can see there is no address, because when you are deploying smart contracts, the recipient of the recipient address is basically 0 address. So this will be not any address, but this will be 0x and 32 or 64 zeros in the case, not 64, but 40 zeros, because the address is to 20 bytes. Okay, so when you are creating smart contract, I can actually draw it here. When you're creating smart contract, I will choose here a new paper. Okay. So when you're creating smart contract, you are creating transactions, right? So you're creating transaction, and you need to provide from this your address from which you are creating transactions from. So this will be your user address, 20 bytes here. Okay, 20 bytes. But to, when you're deploying smart contract, to will be empty address 0x and 0000000, and you will have a 20 of these characters, because we will have 40 of these characters because it's hexadecimal, so it will be in total 20 bytes. Okay, so that's how it basically is. Okay, and about the other parameters, we don't need to talk about right now. What's important that the contract is deployed, and now we can interact with the contract. So on the left side now, you can see here, you can see the storage contract. Now it's residing at this address. So when you create a smart contract, the contract is assigned some specific address here. You can see 0xD91 and so on. That's where your contract is residing. What we can now use here is these two functions, store and retrieve. Okay, that's our two functions here, store and retrieve. With the store, we can store numbers. With the retrieve, we can retrieve the number. So let's store here some number. Let's click here. Okay, I will remove this here. I will clear it out screen, and I will store here number 10, let's say, and I will click here on store. I just click at this. And as I told you, when you want to interact with Ethereum, you want to do changes in a state, you need to send a transaction, and transaction has to be mined. So as soon as I will click here store, new transaction will be sent. You can see here this transaction true, transaction mined and execution succeed. Okay, and then yeah, the execution was successful. You have here from, that's my account here. This will be this account I showed you before, this account here. That's what they are by default selected. And the 2, now actually this 2 is the address of our smart contract. So you can see 0xD914, and that's this address here of a smart contract. You can see in the left bottom side. You have paid some gas for a transaction as the input. Here, this hexadecimal sequence of the bytes. This input is basically the function you want to execute. If you would transfer it into normal letters, this would be this store function. You want to basically call here store function. This is input. Okay, and here we can see here decoded input. That's the value we are sending, value of a 10, and we are calling store function with this 10. So this 10 is stored. Okay, so this 10 is stored, and we can verify with store that we will get the transaction. Okay, we will get some value. Okay, so let's clear it out. Okay, and we can retrieve the value. So let's click here, retrieve. As I will click here, retrieve, you can notice here a very interesting thing here. Now I don't see here any transaction. I can see here something called call, and you can see no transaction has been mined now. When we have been clicking here store, we have been storing, we have been changing Ethereum state. We have to create a transaction. We have to pay for a transaction to do the changes in Ethereum state. But in the case of a retrieve, we didn't have to do this. We just simply got the number 10 back. You can see here we got back number 10 here. And also when I'll get here, I should get here 10. You can see the code output, we got the output of 10. That's the thing. When you want to do changes in Ethereum, in Ethereum state, you need to send the transactions and you need to pay for them. But when you want to get the data back from Ethereum network, you don't need to pay for them. You just simply will get them. Okay, so for one, you need to transaction. For the other one, it's called usually different as a message call when you are getting some values. And usually these functions, that doesn't require to pay for them, and that doesn't require to create the transactions for them. They are marked here as the view functions. View function means that you are not doing any changes to Ethereum state. Okay, but that was just a basic overview about a smart contract. So you have a smart contract. Now it's residing on the Ethereum network. When we want to interact with the contract, we need to, of course, first deploy it, and then we need to send the transactions to a contract, and we need to specify what functions we want to call. In this case, we have been calling store functions. We have been sending the value 10. This stores number 10 to the number, so into the storage here, and with the retrieve functions, when we call the retrieve function, we didn't have to send the transaction, but this was the message call. We got back the number back from the storage. And that's the simplest example of smart contract. I think the best way to learn is by creating and by practical examples. So in the next lecture we'll start, we'll initialize our private network in our local computers, and we'll be creating our smart contracts, and we will learn a lot about them. So guys, that's gonna be it, and see you in the next one. Cheers.